Hi all. Now we are going to discuss a problem on star delta transformation. So here a circuit is given and you are asked to find out the power supplied to the resistive network. So if I want to calculate the total power, then the power equation is P is equal to V square by R or P is equal to V into I. So in both cases we have to find out the total resistance. And the circuit, you can see it over here. It is a little complex circuit when looking at a normal circuit. So here in a normal conventional ways, it is not possible to do an analysis of this particular problem. So therefore, we need to use a star delta transformation. So here we can just observe that a delta network is there, and inside that you have a star network. So a delta and star network is there. So we will see how we can proceed that. So already we have a delta network, and what I can do is that I can convert this particular star network to a delta network inside the existing delta. So that converted star to delta will be looking like this. And we are calculating the resistance between these 2 points. So always keep in mind the point across which we are taking the resistance. If that point is changed, the total resistance will change. So we can do like this, and the next step will be you will be having the two resistances in parallel, again two resistance in parallel, again other two resistance in parallel, converted to single resistances. So we can make it like this, and later it is two resistances in series and that in parallel with the existing resistor, and then we can find out the equivalent resistance. So this is the complete steps of operation of how we are going to proceed with this particular problem. So our first and foremost thing is converting the inner star network to a delta network. So what I will, so all these steps when I am doing, always have a continuation. So write that converting the inner star network to delta network. So what is our inner star? Inner star is this one, and we need to convert it to a delta network. So I will be drawing that corresponding delta using the green color. Excuse me that the drawings are not perfect because it's a little difficult to draw. So I will name these points as 1, 3 and this as 2. And we need to also understand the value of the resistances. So the resistance values are in the inner star are 9, 3 and 6. All these values are in ohms. And I will mark the corresponding resistances as R12, R23, R31. So one thing I am going to do is that I am not going to replicate the formulas which we have learned in our previous lecture. We will just try to solve it using our normal way of understanding how we have arrived at that particular resistance. So R12 is nothing but the sum of the product of the resistances. So that is 9 into 3 plus 3 into 6 plus 6 into 9. So I'll just write like this: 9 into 3 plus 3 into 6 plus 6 into 9 divided by the opposite leg resistor, that is nothing but 6. So you will be getting the answer as 16.5 ohms. Similarly, R23 is 3 into 6, or the same thing, sum of the multiplication of the resistances on the consecutive legs into 9 divided by opposite resistance of R23 is 9. So 9 over here, you will getting the value as 11 ohms. Now we have the last one, R31. Again, a numerator is the same, 9 into 3 plus 3 into 6 plus 6 into 9 divided by the resistance opposite to R31 is 3. Divided by 3, you get the answer as 33 ohms. So now you have the inner star which is being converted to the delta, and that delta you have to draw it inside the existing delta which is shown over here. So I have drawn the outer delta network. Inside that delta network, you need to redraw the new delta form which you derived from the star form. So that I am going to draw it over here. So this is nothing but R12, this is R23, and this is R31. Don't interchange that corresponding values, because if you interchange that, the value of the total resistance will change. So the values of R12 are, R12 is 16.5, R23 is 11 ohms, and R31 is 33. Now it is very easy. Here you have your two resistances in parallel. Here also you have two resistance in parallel. Here also you have another two resistance in parallel. So you can redraw the figure. So 3 ohm and 33 ohm in parallel, you will be getting a single resistance. Its value is 2.75. Then you have 16.5 and 6 which are in parallel. The equivalent resistance is 4.4 ohms. Then you have 11 ohms and 9 ohms in parallel. The equivalent resistance is 4.95. Now, so this is 10 volt. Now you can just redraw this figure. $10 2.75 4.4 and 4.95, it is 9.35. So the equivalent resistance is again 10 volt, and the resistance is 2.125. So therefore power is nothing but V square by R, that is 10 square by 2.125. So you'll be getting it as 47.06. Unit of power is watts. So always remember to write the corresponding units whenever you are doing the problem. So this is how we are trying to solve the problem in star delta. So whatever be the format in which it is given, it may not be, when the problem is given to you, it may not look like a star network to you, but you try to see that you can draw the figure in a star or delta form. So it helps to identify which one can be converted. So in this problem again, it need not, you can also think of other possibilities. You need not convert the inner star. You can also try looking at converting this delta to a star network. So different ways are there, but you try to see that you always find the shortest path in order to arrive at the final value. So this is how we are trying to solve this. Always remember the points which you are taking does not change. If that points get interchanged, then the resistance values will be different. So just imagine that if now in the question it is given these 2 points. Rather than taking these 2 points, by mistake if I am taking this point and this point, then the equivalent resistance will change. So that will give fetch a wrong answer for you. So always remember, whenever you are trying to do the problem, these corresponding points you don't interchange. So it is always better if you keep some kind of markings like 1, 2 and 3 while doing the problems, so which will be easy for you. And you need not mug up the formula just by seeing. And if you want to write the formula, you can just mark it, and then corresponding to that markings, you can just write down the formulas for the sake of answering in the exams and all. Otherwise, it is very simple. By observing at the figure, you can see which formula you have to use. Thank you.